there's a reason why we do door prizes. And Bob, are you here? Is Bob here? Bob wanted to do door prizes, and I guess it must go back to, well, is Roger here? Roger Ellis? To a backcountry horseman. Do you give away door prizes at your meetings? Yes. So that's who we're emulating with this tradition, and it's a lot of fun. But we got plenty more. So when we put this day together, of course, John Bindernagel, Jeff Meldrum, and Bill Lance here is the board. Tomorrow we have Ron and John Monsinski and Cliff and Christopher, of course, last night. Thank you, and Thomas. So I guess this is a man who really needs no introduction. We all know what he's contributed here to our field and our endeavor, and it's immense and very valuable, and it's something that we appreciate greatly. And Jeff continues to be at the forefront of following up on the latest and best evidence, and I think this lecture will show just how what we indeed are going towards, I think, in the future of Sasquatch research. Jeff Meldrum.
So before I get started, kudos for a fantastic event. I mean, as always, Tom.
Yeah.
It makes it such a personal experience and enjoyable, and it's been great. Those of you that were here yesterday, we had a fantastic evening. It's really fun for me to reconnect, and thank you for your patience as I'm rattling through those little file cards, trying to remember where I've seen you before, because it's getting harder and harder. I've met so many wonderful people, and you've all shared so many interesting experiences. All right, you don't have to take notes, which means I'm going to talk fast, because the most challenging thing to do these anymore is to decide what to talk about, what not to talk about in this time only 50 minutes, and if I keep it under 50 minutes, we'll be lucky, but I hope you'll find it worthwhile. So fasten your seatbelt and let's get started. What I'd like to do is to begin by considering a much broader context of where we can put this phenomenon. A lot of times, and I'm sure John will agree, because he's dealt a lot with the philosophical aspects of the progress of science. And a lot of times, if there isn't a paradigm to accommodate a new idea, then it meets with tremendous resistance from the established scientific community. And so I've been working really, really hard these past few years to try to carve, not to carve out, but to, the opening is there, and to anyone that will consider it, it's there. But things have begun to happen, to accumulate, that are creating a broader context for the Sasquatch phenomenon that makes it absolutely rational and expected within the anthropological discipline. So when we talk about, and that's this notion of a relic hominoid. So when we say hominoid, what do we mean? Well, hominoid makes reference to members of the superfamily Hominoidea, which encompasses humans and the apes, both great and lesser. There are other terms that you may have encountered that fall within the finer gradations of that Linnaean taxonomic hierarchy. Like you probably heard the terms hominid, and now more recently hominin, which, as we've applied more strict cladistic methods, a system of classification, have drawn more particular attention to our, let me find that right button. This one's a little different than the last one I've used. Which one's the pointer? Is it right
in the middle?
Right in, oh, there we go, okay. So drawing greater attention to our close relationship to the chimpanzees in particular, we now have a subfamily, Homininae, and when we say hominins, we're referring to those members, those ancestors and close relatives since the divergence from that last common ancestor with the chimpanzee. So I think you'll recognize all these various representatives of their genera here. You recognize that, fellow?
Charlton Heston.
Yeah. Okay. But before before we had this modern concept of primates, if we spread the net even further than hominoids to include the Old World and New World monkeys, as well as the prosimians, the lorises, the galagos, the tarsiers, and so on. Linnaeus had proposed a group, a taxon, called the Anthropomorpha. We break that down, that's the man-shaped creatures. And this was published clear back in 1763, and it was quite interesting because even though there's some artistic interpretation, the walking sticks, that's a tool, an artistic representation of the fact that these creatures weren't very stable on their hind legs. They didn't walk very well bipedally like we do. Not that they walked around using a stick. But many of the details, some of the facial features, particularly the feet, I'm focusing on that, but the artist has captured the essence of an orangutan versus a chimpanzee foot and a baboon foot. We can see an orangutan, a chimp, and even here a gelada baboon, a female gelada baboon, even though the face is quite anthropomorphized there. He even got the details of this little looks like a necklace around her chest there. Well, and in fact, the female geladas have a bare chest that's adorned with a series of little vesicles, which during estrus become tumescent. Looks like a little pearl necklace. So he caught that detail. But Linnaeus also described the troglodyte. This was a hirsute, a hairy, speechless, mute, nocturnal creature that was said to inhabit these, the far corners of the globe. And many just dismissed it as, some derogatory depiction of some ethnic group, perhaps. But the notion that there were man-shaped creatures was quite readily accepted because they were anticipated. They filled in that apparent gap between us and the barnyard animals, and we'll see why that was important. But there wasn't except for those in this room, a recognized candidate to represent that particular group. So Linnaeus, in standardizing this concept of the troglodyte, he made the important distinction to other humans, Homo sapiens. In fact, Homo sapiens means the wise man or the wise ones, and that always kind of struck me as rather egotistical. Sure, we pride ourselves in being rational and being intelligent comparison to the animal kingdom, but really it wasn't so much about that as it was the very close distinction between these two species of humans. He saw this as another type of human. Now, do you recognize that figure? Where is that from? The Voyager. Did you ever wonder who posed for that picture? Look, come on. Charlton Heston's co-star Nova on Planet of the Apes. Isn't that pretty amazing? It's just coincidental that I found that, but thought that was interesting. All right. Now, not everyone accepted or found this notion of a troglodyte as having a basis in science. One of the most vocal and ardent critics was an anthropologist by the name of Blumenbach, a zoologist, a naturalist. Anthropology as a discipline hadn't really taken form yet. But he was quite influential. He was the first to formalize the description of chimpanzees. He argued that this was Linnaeus's great mistake, the notion of a troglodyte, of Homo troglodytes. And he figured that it was just a confused description, mixing the traits of orangutans and humans from Southeast Asia. Now, mixing it just in a descriptive way, not in a genomic way, as some people these days would have it. So this plus sign is only for characteristics, not for genes. Okay, keep that very, very clear. All right, he argued that, actually, Linnaeus did abandon the term anthropomorpha and began about 20 years later. The Systema Natura then was published with the term primates, the first ones, the primary ones. And within the primates, Blumenbach recognized two genera. The genus Homo, with troglodytes gone. In fact, he took troglodytes and hooked it up with pan to make the scientific term for the chimpanzee, for pan troglodytes. Now this figure, I've still not quite figured it out yet, because both these figures in other sources have been labeled as chimpanzees. This one labels this one as an orangutan, but it more clearly depicts a chimpanzee. The limb proportions and the long digits on this one suggest that it's an orangutan. So even back then, as they were sorting out these taxonomies and these descriptions, there was often a bit of confusion. These were new, these were interesting. Now, as I said, the notion that there would be such creatures wasn't unanticipated. I mean, it was expected. Natural theologians who were out there studying nature were doing so to better understand the Creator. We understand the Creator by knowing more intimately the creation. And if the Creator is perfect, if the creation is therefore perfect, it will be perfect in the expression of its completeness. And so we should have this imperceptible gradation from the simplest organisms to the most complex and sublime. And of course, humans are just a little lower than the angels. So here we are, and then right there, the angels, plucking their harps and singing praises, and they're the gods, gods, he, she, whichever persuasion you may adhere to. Okay. This was called the scale of nature, or it was also referred to as the great chain of being. That analogy to a chain is where the expression missing links first came about. So missing links were those forms that would fill the gap, especially this dramatic void between us and even some of these anthropomorphic creatures. Okay, but then we have the formalization of evolutionary biology through the work of Darwin in 1859. The Origin of Species was published. But in one of his notebooks, Darwin drew this figure with this little notation. I think this. And instead of a great chain of being or a scale, he saw nature as a series of ramifying branches diverging from ancestors to offspring or to descendant species. And eventually, when he published his Origin of Species, the only figure he included in the entire book was this one. It was such a fundamental shift in thinking of evolution or of biology, in biology at that time, that it was the only one that was reinforced with this figure, a series of branching lineages, many of which went extinct without further issue. That was contrary to the general idea of things. I mean, what things we see today, it was thought were just the way they were, essentially, is when they were stamped with the Creator's stamp in the Garden of Eden there, named by Adam. Okay, so we had this shift in idea. This notion of the great chain of being gave way to a phylogeny, a family tree. And missing links were no longer links in this great chain of being, but they represented these intermediate forms and these shared common ancestors. So there wasn't a series of independent special creations. There was descent with modification from pre-existing ancestors. All right, now, with that little primer on the notion of how evolutionary phylogeny and classification came into being, anthropology in about the 1960s and 70s. See, right about the time that a lot of the stories of Bigfoot were in their heyday, a couple of anthropologists at the University of Michigan borrowed a much talked about principle in general evolutionary biology called the principle of competitive exclusion. As ecology was taking shape alongside evolution, the notion of a niche was catching on and was taking shape and being developed. And this niche was the kind of the exclusive, just the way a species would make a living and the parameters that defined that. And a species was adapted, was quite evolved to fill that particular niche. And two species couldn't share that because there would always be one that did it a little bit better than the other.
And Gauss, who worked with microorganisms, recognizes if you grew these two species of protists, these little one-celled organisms, separately, they did just fine in very similar conditions. But if you grew them together in the same niche, or the same medium, same medium, this Paramecium aurelia would start off kind of slow, but then it got the upper hand and it became the dominant species and drove Caudatum to extinction every time. So he called this the principle of competitive exclusion. So these anthropologists borrowed that or took that notion and said, well, that must apply. I mean, human ancestors are animal species like any other. And so if we define the hominid niche, and this is a pretty simplistic definition, but that's what it really boils down to, bipedal and brainy, and then the things that go with that. There could be only one species in that niche at any one time. So the evolution of hominids, or now we'd say hominins, since the divergence from that last common ancestor shared with chimpanzees, it was seen as a succession of just one species at a time. In fact, some would say, we don't even really need to call these different species. Everything back to there we can just call Homo sapiens. It's just different forms of human. And that was kind of chic for a while. That dilutes any definitions and understanding of adaptations of any of the populations along the way. But so while depictions like this, how many of you have that book on your shelf? Anybody recognize this? A few of you. This was back before the age of the internet and all the graphics that are available there. I mean, this was where I learned about human evolution when I was a youngster. And this big fold out here, when you have this kind of a graphic, you're kind of constrained as you're trying to depict something that progresses through time. You end up kind of doing it in a linear fashion. It's easy to depict it that way. Sometimes that draws some criticism, but the problem with that is this single species hypothesis really interpreted the evolution as occurring like this. That one species would go extinct as its successor replaced it. There weren't any coexisting at the same time. There could be only one. That's the theme of a movie, isn't it? Remember that? Movie trivia?
Highlander.
Highlander, very good. You're on top of there. Okay. Well, this started to fall apart as the fossil record for hominids began to grow. And here's a depiction of Louis Leakey, not Louis Leakey, that was his father, Richard Leakey, pointing out that fossils of at least 4 different species of hominid were coexisting at the same time in East Africa about about 2 million years ago, 1.5 to 2 million years ago. This is a robust form. This is actually, sometimes it's referred to as Australopithecus boisei, the East African form. Or to make that distinction even more obvious, it was called Paranthropus, parallel to man. And then by this time we've got a pretty brainy hominid, Homo erectus, or the African form became known now as, or is now known as Homo ergaster. This is Homo rudolfensis and Homo habilis. And so one of these may have even been originally the ancestor of Homo ergaster, but didn't go extinct. I mean, you have that split. You don't have to drive the one species to extinction if they can displace their characteristics enough that they can occupy slightly different niches. Maybe there is more than one way to be a hominid, in other words. Okay. So here's a close-up of that, so you can see the beautiful skulls. And notice the difference, notice the distinction here between the Homo and the Paranthropus. We've got this larger brain, we don't have any sign of a sagittal crest, the face is getting a little smaller, and the teeth are smaller, because with those brains they're using stone tools, they're making tools, they have other technologies to assist them, whereas this thing took a different path. Brain, not much bigger than a gorilla or chimpanzee, but look at that deep face, and if we turned it over, the teeth are huge. They're gigantic compared to those hominids. And so we could envision scenes like this. I mean, this was already in that same Time Life Nature book, showing early Homo wielding their pebble tools, confronting a band of Paranthropus, heaving rocks. Common behavior, right? All right, well, things haven't changed much. Oops, I keep pushing the wrong button. It's just that the weapons have changed a little bit. That scene wasn't so unusual to think about. We have not another hominid, but we have another primate, another hominoid living side by side with us. Well, as the fossil record began to grow, not only were there instances of a few hominids side by side, but now there were times when there were as many as 6 or 8. And if you recognize, as has been acknowledged by many researchers who have compared the taxonomic diversity in some of these paleo communities with modern communities of primates and lots of other mammals to get a handle on how spotty is the fossil record. Some estimates suggest that our fossil record only reveals about 8% of the species that existed in the past. 8%. Now maybe hominids are a little more conservative than that, but even if it was just half, this could represent just half of the diversity. There might not have been 4 or 6, there might have been 10 or 12 different species across the globe in different places. Now most of these are centered in Eurasia, obviously, in East Africa, South Africa, places where the fossil record is capricious. So many different types of hominids coexisting. All right, now, in addition to the bushiness of that hominid family tree, recent evidence has also suggested that many of those lineages, those contemporary lineages, have persisted until much more recently than has ever been recognized before. This was really driven home with the discovery of Homo floresiensis, the hobbit, on the island of Flores down in Indonesia. A little diminutive of hominid, different depictions. Here's the one when they were trying to suggest or to justify that it was a dwarfed Homo erectus, because what else could it be? I mean, that's the only other hominid that's around. So it was an island dwarf, a population specific to the island of Flores. But others said, well, gee, maybe it was. I mean, because when I was asked to review the paper that described the postcranial skeleton for a journal, and as I looked at it, first of all, how do you call it Homo? It has a brain that's smaller than a chimpanzee's. Tiny. There was a paper published in Tandem arguing for the association of some very crude stone tools and some controlled use of fire. If you read that paper, it's a very shaky argument, not convincing at all, that this creature had controlled use of fire rather than this was just charcoal that we not in a structured hearth, but on the floor of the cave due to fire. The postcranial skeleton looks remarkably primitive. It looks like one of those Australopithecines. And now all of a sudden at the meetings they're saying, well, this could be a relic Australopithecine that has made its way all the way to Southeast Asia. It's a related species that could be 3 million years old. Of course, Cliff Berkman has been assembling footprints that may come from this thing. The foot is kind of interesting. It has these long lateral digits and it has a very short hallux. So it would not look like our foot at all. And the foot length relative to the leg length is more like a chimpanzee. This thing was probably climbing in trees. All right. Now, on the island of Flores, in central Flores, the native people refer to this as the Ibugogo. That's their name for it. And they claim that 200 years ago, they finally got fed up with these very aggressive, ornery little hominids and decided to extirpate the remaining ones, herded them into a cave, piled up the brush in front of it, lit it afire, killed them all. The remaining, however many, I don't know what the tradition says, but one of the interesting projects I'm involved with is we're seeking permission to excavate that very cave. So we're going over, we've got the funding to go over next spring to do a liaison trip and meet with the Ministry of Antiquities and the academics over there, and then go to Flores with them, meet with the headman and survey the site, see if we can get permission to excavate. Can you imagine the impact, the repercussions if we walk out with a 200-year-old Ibugogo skeleton.
Huh.
So, although it's interesting because this discovery was made literally the week, 3 days before I was giving a promotion seminar in what turned out to be a failed bid for a promotion to full professor. And I thought, how could they not, after seeing this and all the discussions and conversation about this, just completely oblivious to the significance of it. And so anyway, but not everyone. Henry Gee is one of the managing editors of Nature magazine, which I hope you'll recognize as one of the flagship multidisciplinary science journals in England. And he wrote a very interesting paper called Flores, God, and Cryptozoology. I'd recommend you Google, look it up. But he said the discovery that Homo floresiensis survived until so very recently in geologic terms makes it more likely that stories of other mythical human-like creatures, such as yetis, are founded on grains of truth. I even used almost that same slide in this presentation. It's like that Jeff Dunbar peanut. Anyway, but it wasn't lost on everyone. Chris Stringer is one of the preeminent paleoanthropologists of our generation, holds a position at the British Museum of Natural History. And he said, too, during that interview with Henry Gee, he said, one of the first things I thought of on learning about the Flores skeleton was a possible parallel with the orangutan. I had the privilege of going to China on a separate trip, not the one to look for the Yeren, but I was working, trying to develop a collaboration with Dr. Liu over here, who had custody of a remarkable skeleton that he excavated just north of Beijing. Its dates to about 12 to 20,000 years ago. I say that again, 12 to 20,000 years ago. 12,000 to 20,000, but 12,000, I mean, and this is an extremely robust skeleton. Look at that profile. It looks like a Neanderthal, except it doesn't have the highly derived features, the inflated maxilla and so forth, some of the other traits that distinguish Neanderthals from their immediate predecessors, Homo heidelbergensis. Thick cortical bones. I mean, this thing was robust, very robust. Modern Homo sapiens were already in the neighborhood for 50,000 years. So they were living side by side. For 50,000 years, there were other hominids on the block. There goes the neighborhood. They were probably saying that when Homo sapiens arrived. There goes the neighborhood. So if we consider the Asian hominoids, there's Homo floresiensis, 18 to 13,000. There were some early reports of 13, and then some more later dating kind of pushed that back to, but still 18. We have Homo erectus on some of the isolated islands like Java that are down close to 27 to 35,000 years ago. This specimen of Homo heidelbergensis, 12,000 years ago we just looked at. Recently there was the description of a new site of Neanderthal that's only 10,000 based on preliminary dates. 10,000 years, that's almost into historic times. And then Homo sapiens, and then we have the Denisovans, which is quite interesting. 20 to 30,000 years, the most recent specimens of those. And then there was this new population, the Red Deer Cave in southern China, where the crania were quite distinct, and the author stopped just short of erecting a new taxon to accommodate them, but pointed out that this was a distinct population. There was restricted gene flow probably, in order for them to have evolved these different characteristics. And then we have these other, since hominoids also includes apes, of course we have Gigantopithecus, which is acknowledged to have persisted to at least 300,000 years, and in some texts you'll see the figure 200,000 years dropped. And then what was really interesting, teeth that were previously attributed to Homo erectus, that were contemporaneous with Gigantopithecus, found in these karst caves, have now been attributed to Lufengpithecus, which was a gorilla-sized ape. But the real significance of that is that here's another species that has persisted well into the Pleistocene. Well into the Pleistocene, into a time when most of the other apes were extinct, as we'll see in just a moment. But still, we see titles of books like this, Lone Survivors, How We Came to Be the Only Humans on Earth, or the only hominids. He's using the word humans quite quite liberally in this instance. Nova had a series called Becoming Human. The last episode was entitled The Last Human Standing. The previous episodes emphasized this notion of multiplicity of species in the past, and then posed the question, so why are we the only hominins on the planet? Well, are we? And that's the whole why. And why do we keep assuming that in the face of so much evidence to the contrary? And it keeps building, and it keeps building. And that's, so we're getting to the point where it's starting to get a little traction. New Scientist, the popular science news magazine, had a cover feature entitled Human Evolution, the 10 Biggest Questions. The editors got together and thought, what are the 10 biggest issues that paleoanthropologists are dealing with right now? Well, not just paleoanthropologists, but human evolutionists, genetics or whatever. And there's some interesting ones, things we talked about. How did we become bipedal? Long history to that. Are some of us hybrids? That's an interesting. Are other hominins alive today? They interviewed for me. Unfortunately, the assistant editor that got that story, the reporter, didn't do a really great write-up, but it still was a foot in the door, and I wrote a friendly but admonishing rebuttal to it, or response to it, which was published in the Relic Hominoid Inquiry, which you can look up and read. But Gregory Forth is a cultural anthropologist at University of Alberta. About 5 years before the Flores hominin was discovered, he had been studying the traditions of the Nage people. And after looking at their mythology, he focused in on this Ibu Gogo, and he said, there are things about this that don't smack of a mythological figure. They seem to be consistent with, as he called it, an empirical or a hominological reality. He uses the term an empirical species instead of a mythological species. He's one who is helping with the effort to go and excavate. So 5 years before the discovery of Flores, he said, we should watch. This Ibu Gogo may be something different. And then the Hobbit was discovered on the island. And, what else could it be? It has to be an Ibu Gogo. So he has written quite a bit, and has got a lot of traction. He's had provided a couple of very substantial submissions to the Relic Hominoid Inquiry. But this paper appeared in Anthropology Today, and Anthropology Today, Our Legendary Hominoids, Worth Looking For. And he's very sympathetic to the question of Sasquatch. He's experiencing the same sort of thing, though. He can talk about the Ibu Gogo in this context, just fine with scholars. But if he casts the net a little broader, and he starts to run into some resistance and some looks askance and so forth. And so, with this momentum beginning to build, I launched the Relic Hominoid Inquiry. A number of you have asked. This year's been, it's kind of a one-man show. I've been urging my editorial board to jump in there and start submitting some things that we can utilize. But this year I've been a little bit behind. It still is alive and breathing, and still has the blessing of the universities hosting it on the web page, the web server. I promise I'll have a couple of things for 2014 before the year is out. But it I have high hopes that now that we've got it established, that it will make an impact and start to gain some recognition. So y'all, I'm sure you're all fans of the original Planet of the Apes with Charlton Heston. Well, if we go back just a few tens of millions of years ago, the Earth really was, at that time, a planet of the apes. And if we look at the diversity of apes, now remember that phylogeny with all cluttered with all those skulls of hominins, that's represented by that little red line right there. So this is the Miocene epoch, which takes in from just a little shy of 5 million down here to about 23 million years ago. These lines don't represent species, they represent genera. One step up. So each of those bars would actually probably represent several different species. And so you can see the diversity. And these are just a few examples of some of the more stunning crania that have come to light. Just a couple of years ago, this jaw of an ape was discovered and dated to 25 million years ago. So it right now represents the oldest ape skeleton or skeletal material that we have. So right back here at the stem, you can see this tremendous diversity. There's Gigantopithecus right there, and the dotted line then indicates the more recent persistence of Lufangpithecus that I mentioned earlier. Now, if we looked at this, just to show the trend though, apes are high maintenance. A lot of investment in their offspring. They reproduce infrequently. They don't respond to changing environments very, very readily. And so this figure is constructed in such a way that on this axis over here, we have the percent of hominids amongst the anthropoid primates, the monkeys and apes. So down here is low percent, not very many apes. Up here, lots of apes. But then on the mirror image of that is for the monkeys, the cercopithecus. Not very many monkey species and lots of monkey species. And here's time. So this essentially spans the period of the Miocene. And when apes really came into their own and were very successful, very diverse, and monkeys were just barely getting started. Monkeys reproduce very quickly. They respond more readily to changing environments, and they're kind of like the rabbits compared to the elephant over here. If we were comparing in a very extreme way. So through time, what we see is that the apes became less and less and less diverse, and the monkeys, on the other hand, as this line goes down, they're getting more and more and more diverse. All right, so we can think of modern apes really are relic hominoids, as we apply that term. These are lingering populations of a once diverse radiation that are now restricted to tropical refugia and barely holding on by their fingernails, not their claws, but their fingernails. They're on the brink of extinction. Every population on the planet right now of apes is on the brink of extinction, of the known apes. All right, now let's turn the attention to the reason for today. So that in a nutshell is the story of relic hominoids.
What species is Bob?
Yeah, what species is Bob? Well, up here, I think Elvis is in the building. I had to put this one up because I've got quite a few pictures with Bob, and this is the only one where he's smiling. And I had to ask him, Bob, please smile for this picture, And the first one he wasn't. So that's what my other hand is back here, and I'm kind of poking him in the ribs. Smile. Anyway, it's you all know Bob. I can't tell you how what a delight it has been to get acquainted and count him as one of my friends. And so, still, without saying, it's well known that this piece of photographic evidence stands as the most significant piece of photographic evidence that we have to work with. I mean, it has set the bar so high. People are constantly asking me about these little snippets of video that pop up on Facebook, Find Bigfoot or whatever. I said, yeah, they're interesting. But even if I can convince myself that it is legitimate, so what? It is so insignificant compared to this, and we're still arguing about this with so many people. I would much rather spend my time and energy focused on this. And again, you're going to hear some interesting things from Bill. I've had the good fortune of being able to kind of hitch my wagon to Bill and have the opportunity for some collaborations. But he's doing so many really interesting things with this piece of film. It's interesting how there's a kind of a cycle of repeated assails, attacks on the film. And it seems that each time that happens, there are new technologies available that allow us to look at it in different and more incisive ways. Can intelligently or knowledgeably say, oh, that's just a man in a fursuit. You hear someone say that, just try to cover up the snicker. So, obviously, I'm interested in the footprint evidence, in the tracks. And probably first and foremost, although as an anatomist and a student of locomotion, how we move. The anatomy displayed in the film is truly amazing. But today, in the time remaining, I want to nail the lid on this argument about the mid-tarsal break. So likewise, if anyone says to you, oh, he doesn't know what he's talking about, you can go. All right. This photograph was taken by Lyle Laverty, and John Green printed it in his book. But it was never, there was really no discussion or no consideration of what this was, except in connection to these little white twigs sticking out the side of the footprint over here. When I drew attention to this after having seen tracks in the Blue Mountains, not far from here, that displayed the same characteristic, I was told, oh, it's a branch. There's a stick underneath the sand, which is kind of still springy, and it stepped on that, and it just bounced back up, after the weight was taken off of it. Well, it's not. It's not that. I guarantee you, it's not that. First, there's no continuity. The diameter of this ridge wouldn't be congruent with anything attached to that. The cast was made by Bob Titmus sometime later, and about 10 days later, one of 10 casts that he made. In fact, it was quite fortuitous that, and I guess not unexpected, because Laverty had photographed several footprints, each of which was cast by Bob Titmus. So we have that double documentation in a way. But as far as I know, well, here, let me go. No, never mind. I'll hold that thought for a minute. I've jumped ahead of myself. So this is a set of stills from a 3D scan of a cast, a replica made from the cast that Bob Titmus made, the original of which is in the Willow Creek Museum now. It has a very distinctive pressure ridge. It has a very distinctive morphology of the forefoot. There are expansion cracks, as you can see, as that substrate has heaved up to relieve pressure that's concentrated under the forefoot during the latter part of the stance. The major distinction in my interpretation between the Sasquatch foot and the human foot is the human is characterized by a longitudinal arch. Now, and it's a fairly stiff, rigid longitudinal arch. It's mobile to some degree, but as the individual proceeds through the step, those joints twist and lock into a close packed position to make a rigid platform for better efficiency of the flexors of the ankle. And we have this tremendously developed Achilles tendon that's quite distinct. A chimpanzee doesn't have that. Chimpanzee has muscle fibers that go all the way down almost to the heel bone. There is no bungee cord tendon there that acts as an elastic storage mechanism. It can return kinetic energy back into the step. Now, recently, one of my colleagues, because I've also been applying some of these same interpretations to early hominid footprints or hominin footprints, one of my colleagues, in an effort to bolster his notions that the Laetoli hominin footprints from East Africa are just little hominids with modern-looking feet and footprints to go with it, did a test, kind of on the fly test, where he had people in a mall walk across a force plate, and he documented a few people who have a mid-tarsal break. They had a mid-tarsal break. It wasn't as dramatic as we see with the Sasquatch, but they had flexibility here where this star is, and thought that completely discounted my interpretations. Well, far from it. It simply further confirmed the fact that the longitudinal arch is a very recent innovation in human evolution, and it's still variable. And some people have flat, flexible feet still. Not that that they were walking on human-like feet, modern human-like feet, 3 million years ago. And it's because they don't look at the footprints. They measure the length and the breadth, but they don't look at the anatomy. You cannot look at those footprints, as I have, in contrast to modern human footprints in the exact same substrate as occurred on the flanks of Mount Kilauea in Hawaii 200 years ago, and see that they are apples and oranges. mean, as far as the subtleties of I'm seeing apples and oranges, I guess, to the untrained eye. I won't say that my colleague is untrained, just inexperienced. The Sasquatch foot, on the other hand, has this great degree of flexibility, which is a legacy of a climbing adaptation with an opposable big toe. And so the heel comes up, flexes here, weight's concentrated over the forefoot, sparing the toes the bending stresses that have shortened the human digits and allows for longer, more grasping, more prehensile digits, but just non-opposable ones. And then sometimes there's some material heaved up back into the, how are we doing on time? Back into the heel area. So you can see the correlation with the footprint. And here you can actually see the kinematic. You can see the action taking place. If you look right here, that heel is vertical. It's vertical. If there was a stiff arch, the rest of the foot would be sticking in straight to the soil. But it's not, it's bent, it's flexed. And then at this point, the heel is, or the foot is pushing off because by here, the center of gravity is essentially over the lead foot. So it's not using its toes to drive off. The toes are there for traction, not for propulsion. Most of the propulsion comes from that midfoot. Now here's just a little sidebar. Critics have looked at that and say, look at those white feet. They look fake. Look at how that hair just stops right along the edge there. That's got to be fake. Okay. Look, come on, I keep pushing the wrong button. Now, what do you think of that? Do those look like Patty's feet?
Yeah, a little bit.
But they're not. They're a chimpanzee's foot. Showing a mid-tarsal break, showing a white sole, thick skin on the sole, showing the hair up above that glabrous thick skin of the sole pad. Absolutely natural looking. Absolutely natural looking. Even to the little, the little high, next time, those of you that are endowed with more hair on your legs than others, you can see there's actually a little gap that goes up your Achilles tendon a little ways. It's not a perfect straight line all the way back. It has a little, and she shows that if you look carefully on some of the frames. So let's get back to where I was at. Okay, the cast that Roger Patterson made compared with that Bob Titmus made. You can see Roger looked for the cleanest, clearest examples. Did you have any say, Bob, into which ones would be cast? Roger pretty much did. Okay, well, this was a great one. You can see the toe stem's really nice. You can see the outline. You see the little hint of the flexion crease right across here that marks the metatarsal phalangeal joints, which, by the way, if you look back here, look at those long toes.
Yeah.
They're long. They're really long, which isn't suggested by this ventral view here because the sole pad comes way up underneath, just like the palm comes up past your knuckle and produces a flexion crease right across here. There's the hint of that right there. Anyway, I reconstructed the foot skeleton based on this before I ever had contact with this. And then, but if you notice, and I think I got it pretty close to being right, this could all be moved up maybe just a smidge. But in any case, right here is the transverse tarsal joint, and it falls just right in front of that pressure ridge, right where we would expect it to be. All right, now, as far as I know, other than that picture by Lyle Laverty, there were no published pictures of the footprint cast, except for this one. There it is right there. Now, correct me if I'm wrong, but in doing a quick mental run-through of the images, that's the only one. And I don't think anyone even recognized that that was the same cast from that footprint, because you just don't have any sense of the relief there. So the point being, no one had really talked about that cast until I came along post-1996. I didn't start talking about the mid-tarsal break or even publishing anything about it for a couple more years. Keep that in mind as we go ahead here now. Cliff was kind enough to share his contacts with the Crew brothers, and I was at a conference in Portland and was able to go and spend the afternoon with John, and he let me look at that cast really closely. This is the original Crew cast that still is in the family. And look at this now. Here's the Patterson, or the Patterson film site, the Titmus cast, and when it was all cleaned off, in the original photo of Jerry, it still had a lot of soil clinging to the cast. He hadn't cleaned it really carefully, There was a lot more detail between the toes to be seen, and look at this.
Uh-huh.
There's a mid-tarsal break in that joint. It's just shallower, it's not as deep because the substrate's a bit more compacted. But it's there. And look, notice the shape here. We'll come back to that shape again in just a second here. Take a look at that. Okay. Now, again, sometimes it takes a person asking the right question. You know, some of these casts, I've got so much data that I'm still working with. There are things that have sat there that haven't gotten due attention yet, and this was one of those. After finding Bigfoot, made a little obligatory visit to my lab, and then didn't invite me into the field. Where would you go look for Bigfoot? Well, you know, you could, okay, bye, see you later. Of course, when I discovered they hung a rave ball from the trees, I thought, well, it's probably better I didn't go. Anyway, but I love the relationship I have with Cliff, and we reciprocate. I try. Sometimes I feel it's more of a one-way relationship. He's so generous. I try to reciprocate back. But so he had the afternoon off. He came back to the lab, and he was like a kid in a candy store. I just turned him loose, and he comes in the office and says, "Jeff, come look at this." And he had these two casts sitting side by side. He said, "Aren't these the same individual?" They've got to be the same individual. And you know, I said, "Well, you know, I thought about that, but it kind of got pushed to the back burner." Rene de Hinden always made a huge to-do relative to the Blue Mountain material, to the angle of the toe row. And so it seemed unlikely that you could have two individuals, even though they have identical big toes and identical little toes, identical all the toes, to have a squared off toe row and a much more angled toe row in the same individual. But then I thought, well, you know, we have this tendency just to line up a cast according to we drop a vertical line, like a plumb line here, and line them up. I thought, what if we assume for a minute that they are the same, and we force them, the toes, into the same position? What happens? Well, then we see that the forefoot actually lines up perfectly. The only difference now between these two is the angle of the heel. And where's the inflection point? Right at the mid-tarsal joint. Now, if these are prints of one individual, one human subject, who was asked over here to force his foot down and turn his heel in. Now, even sitting there in your chair, if you sit there and with your foot flat on the ground, turn your knee inward and feel what it does to your foot. It twists it and flattens it down, flattens the inside so your arch is closer to the ground if not touching. Over here, he was instructed to turn his knee out and put all his weight on the outside edge of the foot, and then the arch shows up. This motion we call pronation in anatomy, and this we call supination. So if you kind of do it with your hand, pronation, the hand is flattened down like this, and the long axis is lined up. So you have to go to the next one. The long axis is more lined up with the fore and hind foot. When you supinate, kind of like this, it raises the medial border and twists the forefoot relative to the hind foot. The same exact thing that we're seeing here. This cast was made by Wes Summerlin. This cast was made by Paul Freeman. Then I went to China and looked at some evidence. To make a long story short, Mr. Yuan here pulls out a little suitcase and unwraps these two footprints, and I was just floored because there's the pressure ridge.
Yep.
And look at the shape. Here it is in side view. There's no question. It's a pressure ridge. You know, some people, they looked at that and said, oh, that's a bear. This is the forepaw. You know, you see, it has a little bit of concavity. Well, it's a little bit of an optical illusion there. It's rounded, and that is the pressure ridge in exactly the same position. Here you can really see it. Now look at the shape. Right there, that kind of bean shape thing that's going on. That's the placement of, with the foot flex, that's the navicular and the cuboid that are making that kind of double thing there. Here are those bones. So here's the skeleton of this footprint, and that corresponds to that. So when the heel's up in the air and weight's down on the forefoot, pressure is over the cuboid and over the navicular. Okay, then this was sitting in the drawer too. And I had taken note of it, but I hadn't really incorporated it into my argument yet. And then I saw this and I looked more closely. This comes from the blues. And I looked more closely, and look at the shape. Not only does it show the pressure ridge and then along this axis, but again, look at that shape. Okay, now we put all these together. There's China. This was cast in about I always forget the dates. I'm getting bad with dates already, almost as bad as with names. But this was in if I remember correctly, in the late 80s, 89. This was cast in 1967, but as I said, no one was paying any attention to it. No one had copied it until I did in about 1998. And this was cast back in 1984. Mr. Yuan had no clue about Sasquatch. He asked me, so is there anything like, it through an interpreter, is there anything like the Yeren in the United States? Maybe. Maybe. Paul Freeman couldn't have done this, even if he had a notion of a mid-tarsal break. And there have been examples where people have introduced a mid-tarsal break into a hoax to make it look a little more convincing. He wouldn't have. Now, see, I've given away one of these secret characteristics, but I think, like I said, it's ironclad now. It doesn't really matter. There is just, I mean, did you get it? There is no way these are hoaxed. There is no way these three independent things spanning 2 continents and 3 decades of unrelated incidents could be hoaxed. No way. So what does that mean? I mean, yeah. I mean, this is... All right, and then you combine that with the half tracks, which reinforces the mid-tarsal break. And again, look at the angle and the shape there. You can see the slight little indentation, but it's the angle's the really most important part. There it is. Here's the Hereford tracks. Now this one was a little more obscure because it's broken, but you can see the prominence right there, even though it's broken right along that thinner part there, and then the bulge would have come down so that there's the thing right there. Once again, and this is what's so stunning too. This, I don't know if some of you may have already heard this, but it wasn't until I overlapped this with the full-length track that I realized not only do the toes line up and everything, but look at the edges of the half track. They're expanded out to the sides. The impact of running and landing on a more restricted surface area puts more energy into that sole pad and causes it to expand laterally. No way this was faked. I mean, there's just no way this was faked. I mean, you never say never, right? Science is always tentative. And then there's the cripple foot. I mean, the combination of the pathology here that astounds orthopedists and podiatrists, and but yet is dismissed by anthropologists who should know better, should consider it. Okay, so we've got all these converging lines of evidence, plus the film we mentioned, all these showing that this model of the mid-tarsal break of a flat, flexible foot is exactly, is real, and in hindsight is exactly what we would expect. Exactly what we'd expect in a hominid like this, hominoid. Like that. Now, one other little thought. I was on a plane, I picked up a magazine, there was an article about the imperiled status of tigers in Asia, and the graphic jumped out at me because I'd been collecting. In addition, after seeing the Yeren tracks, I started looking more closely at these other Sasquatch-like tracks across Asia. And this graphic, this wasn't the graphic, but it was essentially like this, based on these data. This is the range of tigers in lighter orange as of 1900. And then by 1990, their habitat has shrunk, or their distribution, largely through habitat degradation. And what to think about that conclusion? Oh, wait. Well, look at this. I mapped on all of the footprints that I was aware of Sasquatch-like specimens. Look where they fall. Bing, bing, bing. And there's still some hanging on, presumably up here where the tigers are going on. Now, it doesn't have anything to do with tigers, except the tigers need wet, dense forest cover as their principal core habitat, as does the Sasquatch. Water, sometimes they're called water apes. They're forest apes, water apes. So there's an ecological basis for that. Now, isn't it interesting that clear back when Ivan Sanderson drew his conclusions in his encyclopedic treatment of the subject, he concluded there were 4 types of ABSMs, his acronym for abominable snowman. Well, and now here we are today as we embark on a quest for the relic hominoids. We have the subhumans, the Amasti. We have proto-pygmies, the Orang-Pendek, the Ibugogo, the Indutu. We have neogiants, the Sasquatch, the Yeren, the Mandabarum, so on. And we have the subhominids, as he called them, which are, a species of, by subhominid he means an ape, a species of ape, the Yeti in the Himalayas. So it's been said, there is no history without legend. There is no legend without history. All right, and got to put a plug in. You can't contradict the most famous man in the world, right? Most interesting. You don't have to be famous to be interesting. That's the case. Now, these weren't books, but they said, what can we do with a 3D printer? 3D printer, Sasquatch, 3D printer, Sasquatch. I thought, well, you could do a facsimile of a footprint cast, but that's kind of, you could do a new skull. You could do a new, there was a gentleman who created a new Gigantopithecus skull based on a paper he found that described the dimensions of some isolated Gigantopithecus teeth that were a third bigger than the ones in the jaw that Grover used for his reconstruction. I said, it'd be kind of neat to just highlight that by making a 3D model using the 3D printer. And they said, oh no, we want to do the whole skeleton. I said, what? The whole, you mean maybe half a skeleton? No, the whole skeleton, the whole skeleton. How would we do that? I said, oh my gosh, okay. Well, I would start with a pre-existing model. Let's not try to create it from scratch. So let's take a robust hominin like Neanderthal, a real thick skeleton, that we've lightened, and we're lean, mean running machines and have a gracile skeleton. And there's a pretty complete composite skeleton of Neanderthal that's been created, and you could probably license that from bone clones, and we can 3D scan it. Once we have it in the computer, we can alter it, because Neanderthals have short limbs, they have funny pelvies, they have some different characteristics, and certainly we have to replace the skull. All right, so how are we going to alter it then? What are we going to use as the basis? Well, that's our best model, our most objective, established model. John Green had done some interesting measurements from the film that provided some proportions, even if we didn't go with the absolute size. They said, we want to make it 10 feet tall. 10 feet tall, that's pretty extreme. I said, let's take it down a notch. How about 8.5 feet tall? And they said, okay, well, that's all right. We'll do it 8.5 feet tall. So using these proportions, we came up with, and I borrowed Ruben Steindorf's reconstruction, which he did for Sasquatch Measurement Science, and it has some funny things. He's not an anatomist, but it's still, the proportions are good. He derived this from a very careful analysis of film. I could have gone to Bill. Bill has all these data and probably could have modeled this, but we went this route, and so we went back to the Neanderthal. We got rid of the head. We said, well, let's just replace it with a robust Australopithecine scaled up. Because Gigantopithecus, there's a lot of white plaster around that one jaw. It's a speculative reconstruction, but we have nearly complete skulls of the robust Australopithecines, and they are quite parallel, as I'll show you in just a moment. And so we adjusted, we tweaked our model to more approximate this. We replaced the head, and then, with the outline that John had made from tracing the film, it fits quite nicely. And this credit goes to Spears, R.C. Spears. This was a little sketch that I came upon, and I modified it a little bit and needed to bring the crotch down a little bit. He got the legs a little bit long, so forth. And so the tech ran all this stuff, and he sent me this. And I said, no, we said 8.5 feet, not 10 feet. And he said, that is 8.5 feet. He said the Neanderthal skeleton, the original Neanderthal skeleton, which this is, the original scan, is only 5'6". It's only this tall. And so that is 8.5 feet.